In this video, I wanted to define a function and some definitions associated with these. Let's let A and B be two sets. A function from A to B is then a rule that assigns a unique element, y, in B to every element x in A. So every element in A should get assigned to some element in B, and it should get assigned to exactly one element in B. And instead of y, we typically write it as f of x. So we typically write y equal to f of x. We say y is the image of x under the function f. We also tend to write functions as f, semicolon, and then a arrow b. This indicates that my function is defined by f, and it goes from a to b. Let's suppose I have a function from a to b. The set A is called the domain. The subset of B, which consists of all the images of elements of A, is called the range. So not every element in B has to get hit by this function, but the elements that do get hit are known as the range. Here I have a diagram of a function. My set A consists of three elements, A, B, C. My set B consists of X, Y, Z. We know that A maps to X, B maps to X, and C maps to Y. So for this one, my range would be the set X, Y, since that's what gets hit inside of B. And we can also represent this function by a matrix. The top row are the elements in A, and the bottom row is what they get assigned to. A maps to X, B maps to X, and C maps to Y. Let's consider a function going from R to R, defined by f of x equal to 3x plus 4. And I want to know what is the range. Our instincts probably can tell us that this is a line. Lines tend to look something like this. And we know that it's going to hit every point on the y-axis at some point. So our first guess may be that the range is R. But we want to prove this. So I'm going to let y be some real number. I want to show that y is equal to 3x plus 4 for some x. We can subtract 4 from each side and divide by 3. And this gives it to me so that I have f of y minus 4 over 3 will be equal to y, which is exactly what I want. I got an arbitrary element in the real numbers and showed that there is a number that maps onto this. Here I have a piecewise function. So this function maps R to R. It's defined as 2x if x is an integer and x otherwise. And once again, I want to know the range. Let's consider this in pieces. So let's think of the range of the first piece. We know in this case x is an integer. Well, 2 times an integer is going to be an even number. So 2 times any integer. This is how we define even numbers. So my range will consist of all even numbers. What about the range of the second piece? So this, x is not an integer. So all elements that are not integers would be in the range. Since any number that is not an integer would just output itself. So my total range would be the set of all x such that we need it to be a real number and not an odd integer. Since this one will include everything that's not an integer and this will include all the even integers, the only thing that we don't include is odd. So the range would be every real number that is not odd.